Hello, in this video we're going to use application Flowy14 to write an algorithm that calculates the area and volume of a cylinder whose base radius is r and height h. Let's go into Flowy14 app. Into our dashboard here we'll proceed to design our flow. Let's proceed to the upper left corner where we see commands. Once you click into it, it will open up the left-hand side command menu. You can navigate to each command manually, or you can use this search option up here. So every time to begin designing a new flow, you will need the start command. So let's place it in our dashboard. And for today's purposes, we'll need two input commands, one for the radius and one for h. So let's type in the word input. And it should come up as one of the first available commands. So first input, which is our r, and second for our height, h. Next, first we'll be calculating the area of our cylinder. So we need three mathematical commands. So let's type the word math. By default, they come with the plus sign. So the first one is fine. We'll need an addition here. We'll be adding the radius plus height. But next we'll need two mathematical commands that are multiplication. So we'll turn the plus into multiplication. So let's just add two more of these. And while you have the mathematical command highlighted, you can choose any of the down below options here to turn it into. So for our purposes we'll need multiplication, so click multiply and you can see that the plus sign has turned into multiplication, and we'll need a third one, and we'll do the same here, turn it into multiplication. So this is to, we've designed so far to calculate the area of our cylinder, and we'll need its corresponding output command. So let's type the word output to print the result of our area of the cylinder. And next we'll start connecting the required commands to calculate the volume of our cylinder. So we'll need three mathematical commands, and they will all be multiplications. Math, and we'll turn our pluses into multiplication, and two more of these. Multiply, and the third one. So this is calculating here our volume of our cylinder, and we'll need its corresponding output command to print the result. So let's type the word output, or just out. And once you're satisfied with all of the commands and you've designed your flow, you can close it off by adding the end command. Just type the word end. Alright, so once you've designed your flow, you can click again the upper left corner where it says commands to hide the command menu to have a cleaner view of your dashboard. So now we'll proceed to start connecting our commands. So the formula whilst calculating the area of our cylinder calls for the r, which is the first input command, and h, which is the second input command, to be added. So that's what I will do, clicking into the first input command, which is r radius, and in the green area it's outbound data connector, and once you click into it, in turn you'll have highlighted all of the available inbound data connectors. We'll need to connect it to the first available inbound data connector on the addition command. So click the plus, and once the connection has been made, the plus turns into a minus. We'll perform the same exercise on our height command, or the second input command. So click into its green highlighted area, which is the outbound data connector, and connect it to the second available inbound data connector on the addition command. So click off of the design and you will see the yellow arrows indicating how your commands have been connected thus far. So now next we're just following our formula here to calculate the area of our cylinder. So we'll now need to feed the result of the addition of radius plus height into the multiplication command, and then we'll need to multiply it by its radius, the cylinder's radius. So click into the addition command and in green into its outbound data connector and into the first available inbound data connector on the multiplication command, and then we'll click into our first input command, which is the radius, into its outbound data connector, and we'll connect it to the multiplication through via its second available inbound data connector. And so we are multiplying, we're adding radius plus height, and then we're multiplying the result by r, and then we're gonna multiply this result by 2 pi. So clicking into the third multiplication command, the blue areas are connected to numeric pads. So click into the first blue pad and blue area. This brings up the numeric pad, and we'll need to hard code here 2 pi. Pi is 3.14, so it'll be times 2, 6.28. And that's our 2 pi. That's for the purposes to carry out our formula. So now we'll need to connect to the multiplication the result of the r plus h times r. So the result will be here times 2 pi, and this will calculate the area of our cylinder, and the result will be printed via its corresponding output command. So clicking into the multiplication, the second multiplication area to feed the result into our third multiplication command, click into its outbound data connector and into the second available inbound data connector on the multiplication. Click off of it, and now we'll need to feed the result to our output, to its output command of the area of our cylinder. So click into the result, the third mathematical command, into its outbound data connector and into the only available inbound data connector on our corresponding output command. Okay, so the first part of our question has been completed. Now we'll proceed to calculate now we'll proceed to calculate the volume of our cylinder. So we'll need to perform the r squared. So to our first mathematical multiplication command, we'll connect our first input command twice, which is the r squared. So click into the first input command, which is r radius, click into its outbound data connector and connect it twice. Click on both pluses on the first multiplication command, and that will in turn will give us the r squared, radius squared. Then we'll need to feed the radius squared here, and we'll need to multiply it by r height. So click into the multiplication command and into its outbound data connector in green, and into the first inbound data connector in green onto the second multiplication command. And now we're clicking into the second input command, which is our height, into its outbound data connector, and we are connecting it to the second from our volume here formula to the second multiplication command via the second input data connector to carry out the formula, which is r squared times height, and now we'll need to have that multiplied by pi. So into the third multiplication command, we're clicking into it and into the first in blue input data connector, inbound data connector. It's got numeric pad, and we'll hard code it here the pi equivalent, which is 3.14. Okay, so now we just need to feed over our result here, which is the r squared times height. So click into the second multiplication command with the result into its in green outbound data connector, and connect it via to the third multiplication command via its second inbound data connector. So now we're multiplying r squared times height times pi, and this is the calculation of our volume of our cylinder, and now we just need to print it via its corresponding output command. So click into the result where we calculated the volume of the cylinder into its in green outbound data connector and connected via the only available inbound data connector on its corresponding output command. So let's click off of the design and just make sure that we have connected our commands properly to carry out the formulas. So this is our R, again this is height, and once we execute the flow, the system will ask us to input a value for each. So we're adding our radius plus height, and then radius plus height times R, and then this times 2 pi, and so this is our area of our cylinder, and then we're having r squared times our height, and then the r squared times height times pi, and this is our volume of our cylinder. Okay, so we've designed our flow, we've connected the commands, we are ready now to execute the flow. Click run. So we're being asked to enter the value for our radius. I will choose 3. And I'm being asked to enter the value for my height. I'll choose 5, enter. And we're just carrying out the formula. So 3 plus r plus height, radius plus height 8, 3 plus 5, 8. 8 times 3, 24 times 2 pi. So this is the area of our cylinder, and then we are squared. We are doing radius squared, so 3 times 3, this is our radius, and then times our height times 5, and this is volume of our cylinder. So this concludes our exercise that using application Flowy14, we wrote an algorithm that calculated the area and the volume of cylinder whose base R and H we were given. Thank you.